screenshot of the syllabus objective as of 2020. So at O levels, dot and cross diagram that you need to know are actually hydrogen, oxygen, water, which is H₂O, methane, which is CH₄, and carbon dioxide, which is CO₂. Of course, they can definitely ask you how to draw dot and cross diagram of the other molecules. But if you know the basics, alright, you definitely will have no problem in drawing the other molecules. Alright, let's start off with hydrogen. Now before we even start drawing dot cross diagram, we need to determine how many electrons this particular element has. Okay, so now we're dealing with hydrogen. Hydrogen is over here in the periodic table. And how would I know how many electrons it has? Now back to our atomic structure, we know that in an atom, the number of protons and electrons must be the same. Now in the periodic table that you have in exam, okay, you can just refer to the key to know what each of the number represent. Alright, so the top of the number actually is the proton number, or not, we can say is an atomic number, which means it is the number of protons. Now in an atom, number of protons and number of electrons are the same, and hence we can safely say that the number at the top also represents the number of electrons in an atom. So hydrogen, the number of protons is 1 and number of electrons is the same, okay, it is also 1. So each hydrogen will have 1 electron. When you are drawing a dot and cross diagram, you must actually write down the symbol in the middle of the circle. The circle represents the electron shell. We actually know that hydrogen has 1 electron. I will just draw a cross to represent 1 electron. Now based on the chemical formula, there are 2 hydrogen atoms in this molecule. Alright, for better visualization, let me draw another hydrogen and I will use dots to represent the electron for this second hydrogen. So these 2 atoms, they have not attained the noble gas electronic configuration. If they only have 1 shell, they can only fill up 2 electrons in the first electron shell. So if that particular atom has only 1 electron shell and it already has 2 electrons in the outermost shell, then it is stable. So if you refer back to the periodic table, this particular element is actually helium. Helium, it only has 1 shell, okay, and it already has 2 electrons in the first shell. So if that is the case, it has already achieved noble gas electronic configuration. So it is stable and it's not going to react. But hydrogen in this case, each of these hydrogen has 1 electron shell and it only has 1 electron in the shell. It has not attained noble gas electronic configuration. It needs to undergo chemical reaction to form a covalent bond. So when they come together, what will happen is each of them will share 1 electron. Alright, so hydrogen, hydrogen, each of them will share, and we represent the sharing by drawing the electron in the overlap region. So let's refer to the hydrogen on the left. For this hydrogen, it has 2 electrons in the electron shell. The other hydrogen, it also has 2 electrons in the electron shell. Okay, so each of them is happy. Each of them has attained noble gas electronic configuration, hence H₂ is formed. So if I'm to convert this dot and cross diagram into the structural formula, I'm going to write this down. This dash that I draw here is a single bond, okay, meaning there's only 1 bond. And from here, you can actually see that 1 bond is formed when 2 electrons are shared. Now the next substance that we are going to try drawing is actually oxygen. Oxygen is over here and there are 8 electrons. Okay, as mentioned, we will need to write down the chemical symbol of the element in the middle of the circle. Alright, that will be O. Now an oxygen has 8 electrons. The first 2 electrons must be in the first shell. So let's use cross to represent. Okay, so this particular oxygen has 2 electrons in its first shell, and the remaining 6 will be in the second shell. Now based on the chemical formula, okay, it is O2, so I have another oxygen, alright, that I'm going to draw here, and let's use a dot to represent the electrons. Alright, so again, the first shell has 2 electrons, then the second shell will have my remaining 6 electrons. So now each of them has 6 electrons in its outermost shell. So each of them needs 2 more electrons to attain the noble gas electronic configuration, which for the second shell, they must have 8 electrons. Then what they can do is, each of them will just share 2 electrons, okay? So the first oxygen, 2 electrons in the inner shell, then share 2 electrons here. The remaining 4 electrons will not be shared, okay? So we have 2 here, 3, 4, 5, 6. The other oxygen, same thing, has 2 electrons here in the inner shell, alright, and it shares 2 electrons. Okay, so 1, 2 is shared here. The remaining 4 electrons are not shared. So if we refer to the oxygen on the left, the outermost electrons that it has now is actually 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it has already attained the noble gas electronic configuration. The second shell needs to have 8 electrons. What about the electrons on the right hand side? Okay, electrons on the right, it has 1, 2, 3, 4, 5, 6, 7, 8. So now you realize that this oxygen has achieved noble gas electronic configuration also. Now in exams, you are more commonly asked to draw the outermost electrons. So what you're going to do is omit, okay, this particular shell and this particular shell. Okay, so for clarity, let me show you how to draw that over here. So what you're going to do is just show this dot and cross diagram, okay? You don't need to show the inner shells. Now again, you should only draw this if question asks you to show only the outermost electrons. So from here, how do we write down the structural formula of this oxygen? Now we can clearly see that between 2 oxygen atoms, 4 electrons are shared. Alright, as mentioned just now, 2 electrons form 1 bond. So if there are 4 electrons shared, there must be a double bond. Okay, so this is the structural formula of an oxygen. Now let's try the next one, water. Now just now we have already referred to the periodic table. We know the hydrogen has 1 electron. Okay, so let's draw a cross to represent that. So each of the hydrogen has 1 electron. Oxygen has 8 electrons, alright? 2 electrons are in the first shell. The second shell has 6 electrons. So we know that hydrogen has only 1 shell and it needs 1 more electron to attain the noble gas electronic configuration. For oxygen, it has 2 shells. Okay, so the second shell needs to have 8 electrons to attain the noble gas electronic configuration. So what they can do is each of my hydrogen just share its 1 electron and oxygen share 2 of its electron to each of the hydrogen. So a dot and cross diagram for a water molecule will look like this. O, now if the question asks for only the outermost electrons, then what you can do is omit the inner shell and show only the outermost electrons, right? So this is what you can draw. Now from here, let's convert this to structural formula. So you can see that there's only 2 electrons shared between hydrogen and oxygen and another 2 electrons shared between the other hydrogen and the oxygen. So between each of these hydrogen and oxygen, there is only 1 bond, alright? So we can draw this. So this will be the structural formula. Now you realize that in most of the structural formula that you have seen, this water molecule usually have this V shape. Okay, at O levels, this is not particularly important. We will only learn about how these atoms arrange themselves in a molecule at A levels. Okay, you'll only learn that in detail. At O levels, if you draw something like this, a straight line, you shouldn't be fault. Because what is important is whether you know how many bonds are shared between the atoms rather than the shape of the molecule. Now what about CH₄, which is methane, our natural gas? What is the number of electrons of carbon? Now carbon is over here. Okay, it has 6 electrons. the first shell can only hold up to 2 electrons. Okay, so carbon, 2 electrons in the first shell. The remaining 4 electrons will be in the outermost shell. Okay, then the rest are all hydrogen. Hydrogen, it has only 1 shell and 1 electron. Alright, so my carbon has 4 outermost electrons. It needs 4 more electrons to attain the noble gas electronic configuration. So I have 4 hydrogen. Okay, each of these hydrogen just share 1 electron with this carbon. Okay, so what we will have is, write and see, okay, inner shell, and all the 4 electrons are going to take part in the sharing. Alright, so we'll draw all in the overlap region. And I got 4 hydrogen. Okay, and each of these hydrogen will share 1 electron. So now, if we focus on carbon, has the carbon attained the noble gas electronic configuration? Okay, let's count now. Alright, we have 2 electrons, 4, 6, 8. The second electron shell, which is the outermost electron shell, okay, it has 8 electrons, so it has attained the noble gas electronic configuration. For hydrogen, each of them has 2 electrons in the outermost shell after sharing. Okay, so each of them has attained the electronic configuration that they want. So this is the correct dot and cross diagram that you should draw. So again, if question asks you to only show the outermost electrons, what you will need to draw is this. Okay, we actually omit the first shell of carbon. So for the structural formula, again, there will be 1 carbon, 4 hydrogen, and between carbon and each of the hydrogen, a single bond is formed. 1 single bond represents the sharing of 2 electrons. In fact, this is particularly important, okay, when you do organic chemistry. In organic chemistry, you very often need to write down structural formula of the organic compounds. A very good way to determine whether or not you have drawn the correct structure is to count the number of bonds. Carbon always have 4 bonds because it will need to use all its 4 electrons for sharing. Now what about the next one? Okay, we have carbon dioxide. Carbon, as mentioned just now, okay, there are 6 electrons. So first shell will have 2. Alright, the remaining 4 are in the second shell. Now for oxygen, there are 8 electrons. 2 electrons in the first shell, 6 electrons in the second shell. So now from here, we know that oxygen needs 2 more electrons, carbon needs 4 more electrons, and we have 2 oxygen. So carbon will share 2 electrons with 1 oxygen, and the other 2 electrons with the other oxygen, and they will come together to form this. So all the electrons of the carbon are shared, so we draw all in the overlapping region. For oxygen, the innermost electrons are not involved in bonding, so each oxygen uses up 2 electrons for sharing. The remaining 4 electrons are at the outer part of the overlapping region. Same thing for the other oxygen. Okay? Now after you draw dot and cross diagram, it is always good for you to check whether or not each of these atoms has attained noble gas electronic configuration. So let's check for the oxygen on the left. Okay, we got 4 here, 5, 6, 7, 8. Alright, so this oxygen attained noble gas electronic configuration. Good. What about the carbon in the middle? We got 4, 5, 6, 7, 8 over here. Alright, so good for carbon. What about the oxygen on the right hand side? 4 here, 5, 6, 7, 8. So each of them has attained the electronic configuration that they want. Alright. So again, in exams, if they ask you for only the outermost electrons, what you will need to show is this. We omit the electrons at the inner shells. So this is what you need to show if you are asked to draw only the outermost electrons. So let's convert this to structural formula. So from here, we can see very clearly between each carbon and oxygen, 4 electrons are shared. So if 4 electrons are shared, it means that 2 bonds are formed. So between C and O, we just need to show a double bond and a double bond. Now if you find this video useful, please share with your friends. Don't forget to subscribe to the channel and like the video. If you'd like to have more chemistry resources, do check out my website. The link is in the description below. Now have fun learning chemistry, and I will see you soon.